Okay, so we have been talking about how there's this constant battle between kinetic energy trying to pull molecules apart and what we call intermolecular attractions or attractions between the molecules trying to hold the molecules together in a particular state. And so I want to take a little bit of time just to talk a little bit about water and surface tension and how that relates to intermolecular attraction. So if we look at a water molecule, okay, with this being our oxygen and this being our two hydrogens, and okay, so I want to make sure I'm not in the way there. These guys, when they're forming a chemical bond, they share electrons, but they don't share them evenly. And remember, your electrons are your little negatively charged particles. And when atoms share electrons or steal electrons from each other, that's what a chemical bond is. Well, the oxygen tends to hog the electrons when it bonds with the hydrogen atoms. And because electrons are negatively charged and the oxygen hogs the electrons, it gives this end of the water molecule a slight negative charge, okay? The hydrogen ends get a slight positive charge because they have more protons than they do electrons because the electrons are spending more time by the oxygen. Because of the fact that the molecule has a positive end or a positive pole, like North Pole, South Pole, and a negative end or a negative pole, we tend to call water molecules polar, okay? Because they have polar ends, like a north and a south pole. But this feature of water molecules tends to make them sticky, and they want to stick together. So this water molecule would be attracted to the positive ends of another water molecule, okay? And this end would be attracted to the negative end of another water molecule. And it's because of the fact that opposite charges attract each other that the water molecules tend to stick together. And I have an article that I've enclosed for you to kind of help you understand how this works and explains why the water molecules are going to stick together. If you look at this bottom diagram, very, very cool, it's showing you a water droplet and why water tends to bead up on a surface, okay? It shows us that the water molecules beneath the surface are pulled in at all directions. So they're more attracted to the water molecules below the surface than they are the air molecules that they're exposed to. And it kind of causes them to pull in towards those other water molecules and forms this beaded shape. So I don't know if you've ever done this experiment, perhaps in 6th grade. But what this is showing you is drops of water. I took a beaker, okay, and I used a little water droplet or dropper, a pipette, and I dropped little drips of water onto the surface of a penny. And pennies can hold, anywhere from like 40 to 50 drops of water without it overflowing the surface because the water molecules are so attracted to each other. Now, this attraction between the water molecules that causes what we call surface tension, this elastic-like surface of a liquid, is what we're talking about when we're talking about intermolecular attractions. So if we were to heat water up, we would cause the molecules in the water to start moving faster, gain more and more kinetic energy until the point that those molecules could escape their intermolecular attractions and escape the liquid surface and become a gas. Okay, with my next demonstration, what I'm going to do is I have a glass of water here, and I have a cup of Dawn dish soap, like dishwashing soap, and I have a toothpick, okay, and some pepper. And what I want to do is illustrate just how attracted water molecules are to each other, but you're not going to be able to see the breaking of the attraction between the water molecules unless I put some pepper on the surface. Okay, if I don't include some pepper on the surface, you won't know that the water molecules are even moving. Okay, so I want to show you how water molecules are attracted to each other, and you can break that intermolecular attraction by putting in some soap. So I'm going to just gently touch the soap to the surface of the water so I can break the surface tension and break up the ability of those molecules to attract each other. And you're going to be able to observe it by watching what happens with the pepper. Okay? All right. Okay, in my last demonstration, I have a series of water droplets on the surface of just kitchen wax paper. And wax paper is made up of a bunch of what I would call hydrophobic molecules, in other words, water fearing. So because of the lack of charge on the molecules that make up the wax paper, there's no attraction whatsoever, as you can tell, between the wax paper and the water. The water tends to stick together in droplets because of its polar nature, the intermolecular attractions between the molecules. And I just want to show you just how attracted these molecules are to each other. If we kind of grab a hold of one molecule and push it towards the other, they'll join as one big water molecule. If I take my wax paper and I move it around and I kind of try to split the water molecule apart, I can't, because the water molecules are so attracted to each other due to their intermolecular attractions. You can really see it when you put it on this surface that's hydrophobic, okay? And so the only way I can kind of get this water droplet to split apart is if I move it really, really quickly. And if I move it super quickly, then I can kind of pull it off and pull that water molecule apart. But again, when you kind of play around with those water molecules on the wax paper, you can see just how attracted they are to each other and those intermolecular attractions and surface tension.